We'll look at number 9 right now. Number 9, we'll just solve this system by using Kramer's law. So the first thing we want to do is find the determinant of this, of our coefficients. So let's just start by finding that. 1, -3, -2, 3, 2, -6, 4, -1, 3. Copy the first two columns since we're using the diagonal method. 1, 3, 4, -3, 2, -1. So before we start that, determinant A will be defined by the sum of the first diagonal and take away the sum of the second diagonal. Alright, so diagonal 1 will be defined by this. So diagonal 1 is equal to 6 plus 18, 18 times 4, 72, 6, you get 84 for the diagonal 1, diagonal 2, will look like this, 4 times 2, so -16 first. Then we have -1 times 6, so +6, so -10, and then -27. So this is equal to -37, it looks like, but let's just double check. +6, -27, yep, -37. So the determinant of A is equal to 84 minus -37. So plus 37. So 84 plus 37 gives us 121. So 121 is our determinant. So we'll say 121. So determinant, let's solve. We're going to solve all three variables using the determinant rule, so let's start it. So x is equal to the determinant of x divided by the determinant of A, which is equal to, so what we do, if you recall, is we replace the constant right over here. 9, 20, 25, 1, 3, 4. Oh, why did I do that? Just redo that. So x is equal to the determinant of x divided by the determinant of A, which is equal to, determinant of x would be 9, 20, 25, which represents the constants, and then -3, 2, -1, -2, -6, 3. Yep, that looks good. You only replace the x, y stay the same, z stay the same. Copy the x and y's, 9, 20, 25, -3, 2, -1. So let's start it, and then divide it by all 121. But let's first focus in on determinant x to solve for it. What we're going to do is find the diagonals, so let's find diagonal 1 first. So 9 times 2 times 3, so 9 times 6, 54. So 54. 3 times 6 times 25, plus 450. Yeah, 450. 2 times 20, 40. 54 plus 450 plus 40, 544. Diagonal 2. Will be equal to 4 times 25 25, negative 100, plus 54, 9 times 20, minus 180, 100 minus 180 plus 54, negative 226. Okay, with that, we get our determinant x is equal to 544 minus negative 126, which means it's plus 544 plus 226 gets you 770. So if we plug this into the formula, 770 divided by 121, let's see, maybe 11, 770 divided by 11, yep. So we divide both of it by 11, you get 70 over 11, so that's our value of x. So x here would equal 70 over 11. It's our first answer of many to go. Alright, so we're going to solve for y, and then we can solve for z over here, and we'll be done. Alright, next let's solve for y. Y is equal to the determinant of y divided by the determinant of the coefficient a. So we have 1, 3, 4, 9, 20, 25, negative 2, negative 6, 3, 1, 3, 4, 9, 20, 25. As we recall from the last problem, we just copied the constants right there. So let's go from there. Divide it by 121. So let's start by finding the diagonals. So diagonal 1. Will be equal to 20 times 3, 60. 9 times 6 times 4 gets us minus 216. 2 times 3 times 25, minus 150. 60 minus 216, minus 150 gets you minus 306. Let's find diagonal 2. Diagonal 2, 4 times this, this, this. So 4 times 6 times 20 gets you minus 120. 4 times 20 times 2, yep, or 160, oops. 4 times 20 times 2 gets you negative 160. It's a negative 160 right there. Ooh. 4 times 20 times 2, negative 116, 60. Then we have 25 times 6, minus 150, and then 3 times 9 gets you plus 81. So 160 negative minus 150 plus 81 gets you minus 229. So the determinant of y is equal to negative 306 minus, which becomes plus 229. Negative 306 plus 229 gets you negative 77. So from here, this is equal to negative 77 over 121. I see they both share 11, so it becomes negative 7 over 11. So that would be our answer for y. Y is equal to negative 7 over 11. All right, we're on the last part of it. We'll just do it right over here. I'll give you about 10 seconds to copy this down, or you can pause it, because I want to look up at the back of the original equation above so we can just see what we're doing, okay? Alright, so we look back over here. We're solving for z now, our last one. Z is equal to the determinant of z divided by the determinant of a, which is equal to 1, 3, 4, negative 3, 2, negative 1, 9, 20, 25, 1, 3, 4, negative 3, 2, negative 1. Since we're solving for z, we replaced our coefficient of z with our constants, and at the end of the day, we divided by a, which we got is 121. So first off, we have right here, let's just start finding our diagonals. Diagonal 1 would be equal to, okay, we're going to find the product of all those. So 2 times 25, 50. So 12 times 20, 12 times 20, negative 240. Then 9 times 3, minus 27. 50 minus 240 minus 27 gets you negative 217. Let's find diagonal 2. So diagonal 2 is 4 times 2 times 9 gets 72. So negative 20 would be the next one. Then 25 times 9, 25 times 3 times 3, minus 225, 72, minus 20, minus 225, gets you negative 173. So to find the determinant of z will be equal to negative 217 minus, which becomes a plus 173. 217 minus plus 173 gets you negative 44. So we can plug this back into the equation, which is equal to negative 44 divided by 121. Both share 11, so we get negative 4 over 11. So our final answer, z, is equal to negative 4 over 11. So our answer set would be, x would be 70 over 11, negative 7 over 11 for y, and let's do it again. X is negative 70 over y. Y is going to be negative 7 over 11, and z is negative 4 over 11. That's our answer set.